So what's typical for me is whenever we have this box of a definition, I'm going to share the answer key just so I don't mess up anything. Now, with the fundamental theorem of calculus, it's basically saying the antiderivative for a definite integral, as long as that function is continuous, is, if you're asked to do the integral from a to b of f of x dx, it's equal to the antiderivative when you plug in b in for x, the upper bound, minus plug in a in for x, the lower bound. So right now this might not make a whole lot of sense. Notice that capital F is the antiderivative of lowercase f. It's just kind of how we write it in calculus. So you might want to just pause the video and write this down. And it's the first fundamental theorem of calculus. There's a second part to it as well, but we're going to save that for a little bit later. So just getting right into an example. And we've actually done this before. If we're asked to find the integral from -2 to 1, well, if you look at this problem, I think it's pretty clear that the area under the curve here, if you look at that, and you could actually just count the boxes the way it's set up, but I'd actually break it up and see that this rectangle is an area of 3, and then the other triangle, if you did the formula there, is 1/2 times the base is 3 times the height is 1, 2, 3, 4, 5, 6. If I did my math right there. So I believe the answer should be 12 to this. But if we actually work this out, what you do is the integral, or antiderivative, where you add 1 to your exponent and you divide by that new exponent. Well, 2 divided by 2 is just 1, if you want to write that down, plus 3x. Notice that I'm leaving off the plus c, and then you have your bounds from -2 to 1. So what you do is you plug in those values. So plug in 1 in for x. Well, 1 squared is still 1, and 3 times 1 is 3. And then plug in -2. Well, -2 when you square it is 4 times -1 would be -4. And 3 times -2 is -6. And then you subtract those values off. Well, notice that I end up with 2 minus -10, and I get an answer of 12, exactly what I predicted. So I like how it's set up where, you could look at the problem and you can just say, oh, yeah, that answer looks like it makes sense. And this answer looks like it's exactly -12 as well, because if you really break it down, it looks like the same exact figure. But why is it negative? Well, it's below the x-axis. The curve is below the x-axis, so my answer should be negative. So let's see if that's true. Well, the antiderivative is the same, because it's the same problem, same graph. But this time it's from 2 to 5. Now as I plug in 5 first, well, 5 squared is 25. 3 times 5 is 15. Minus 2 squared is 4 again. But this time it's plus 6. So as we do that, we're looking at -10 minus 2, and just like I predicted, we'll get -12. There you go. So feel free to pause at any point or rewind and see if you get the same answers. Really the same thing. I didn't realize that there were so many that were the same here. But as you notice this one, -1 to 4, I believe what happens here is the area above is exactly the same as the area below. So it looks like, so they should cancel each other out, because remember, above the x-axis is positive, below the x-axis will be negative. So I'm just guessing that this answer should be 0. Well, let's see, because we should plug in antiderivative, from -1 to 4, and as I now plug in those bounds, so 4 squared is 16, 3 times 4 is 12, minus -1, because -1 when you square it's positive, but the negative's still there, plus -3, so we're looking at, looks like -4 minus negative 4. Yeah, I think I was right. It's equal to 0. So some interesting things to pick up on. And then from negative 1 to 3, I'll let you just work through this one a little bit on your own, because I kind of want to get to more interesting problems. We should get a positive answer because the area above is larger than the area below. And then same thing on this one. We should get a slightly negative answer, 0 to 5, because the area below the x-axis is larger than the area above. How about this? Try it on your own. You can pause it, and I'm going to flip to the answer key and share those last two answers. Looks like this one's 4, and this one's negative 10. Let's just stick with those, because I know I'm going to forget something. Yeah. So as we move forward, the integral from a to b of f of x dx, first thing is you might want to recognize it's the area of the region bounded by the function, that's the curve, and the x-axis, and then the vertical lines x equals a and x equals b. If the integral equals 0, then the area above the curve would be equal to the area below the curve, so everything cancels out. And then number 3, if you get a positive area on, that's what greater than 0 is, then there's more area above the x-axis than below. And then on the flip side of that, if you get a negative answer, less than 0, then there's more area below the x-axis than above. So there you have it. So as we move into more complicated problems, you can use a graphing calculator to double check your answers. And just so you know, right, I don't have the keys on. I'll just have to find it later. With a graphing calculator, it's under the math tool. And what's nice about the TI-84, at least the plus CEs, the pluses might have it as well, is the calculator looks exactly like this. So if you type into a graphing calculator under the math tool, I think it's integral, int maybe, and you type it in, it'll just spit out the answer for you. But what if it's a no calculator test? Well, if it's no calculator, you actually have to figure out what the antiderivative is. Add 1 to your exponent, divide by 2. Well, that cancels out that 2. Don't worry about the plus c, and we're looking at from negative 1 to 2. So plugging in 2, you get 4 minus 2 cubed is 8. And then you're going to subtract off. When you plug in negative 1 squared is 1. Negative 1 cubed is a negative, so it turns into plus 1/3. And it might be worth your while to change this to be 12/3 is equal to 4. 12 minus 8 would be 4/3 minus, 3/3, so plus 1/3 would be another 4/3. Things will cancel out and you get 0. And instead of using a graphing calculator to check, answer key also gives it. Which is, I'm glad I went to the answer key, because remember, we can only do these problems if the function is continuous. Well, as you look at 1 divided by x squared, x cannot equal 0 there. It's a discontinuity there, which would say, well, we can't exactly find this area from negative 2 to 3. Now, it's very rare that an AP test would ask you to do this problem based off of this discontinuity. So it's really not feasible for us to solve this. And you could look at a graph and actually see what that answer is. All right. By the way, if anybody's struggling to use a graphing calculator, feel free to bring it up to me in class in a Google Meet. Let me know. We can work it out. So as I'm looking at the next one, this might be a good place to stop if I get through these next two, is because it's a giant division with a monomial, I would rewrite this integral, just rewrite that as 2x over x squared is the same thing as 2x divided by x squared, so it's 2 over x, but I'm going to write as 2x to the negative first, and then plus 3x to the negative second, because remember you have to divide each piece. I don't know why I wrote it so high, but anyway. So then, as a reminder, this is the integral is 2 natural log of x, because remember we talked about this. If you were to add 1 to negative 1, you're at 0, and you can't divide by 0, so something was wrong there. Adding 1 to negative 2, but then we have to divide by negative 1, so that's why I changed that to be a minus 3 from 1 to 4. And then from here, we need to just type, plug it in. And remember, to the negative 1 power means divided by. Now, if this were a multiple choice question, my guess is they probably would not leave this answer alone. But they do expect you on the AP test to know that natural log of 1 is always 0. So really what our answer is, if you want the exact answer, would be 2 natural log of 4 minus, it'd be negative 3/4 plus 3, which if you had the same denominator would be 12/4. So negative 3 plus 12/4 would make that plus 9/4. And it's only natural log of 4. So if you want to move that 9/4 in front because it's commutative, that would probably be fine as well. Which is exactly what this author wrote. And apparently this last answer is pi squared. So if you feel like pausing it, trying to work it out on your own, otherwise you're going to get my explanation here shortly. Oops, I don't know what I just did. There we go. So the antiderivative of that would give me x squared divided by 2 would cancel that out. And then the derivative of cosine, remember, is positive sine from 0 to pi. Now I can plug this in. We get pi squared plus sine of pi. Now be careful. Don't automatically assume that plugging in zeros will give you zeros, because what if this were cosine of 0? Well, cosine of 0 actually equals 1. I just said cosine, but I meant to write sine. But in this case, sine of 0 is 0. Just recall the unit circle. 0 is right here at this ordered pair. So sine is the y-coordinate. It is 0. So this happens to all be 0 over here. Sine of pi is at negative 1, 0. It's 0 as well. So that's why we're just left with pi squared plus a bunch of zeros. And this is a great place to stop. So you might want to hit pause and watch my work. Hopefully it all made sense. And we can finish up with some tables, answering some questions, and then you'll be ready for the homework.